Okay, so in the last class, we learned two identities, which is cos square theta plus sin square theta is equals to 1. And the other one is tan theta is sin theta upon cos theta. You have to learn these. They will give you will have these in the formula booklet, but it's better that you memorize these because these are only two of them, so not so very difficult to memorize. So let's do part E. Okay, one thing that you people may need, or this will help you make your work easier to write, quicker to write. It will increase your efficiency. For example, this is the question that they're giving you. It is sin x minus cos x upon sin x plus cos x is equals to similar to tan x minus 1 upon tan x plus 1. Now, the technique which I'm going to tell you right now, I have used this myself in the exam to make my work easier, to make my work more neat. So what do I do if this is the question that I have in the exam? So first of all, I would start by let S is equals to sin x, C is equals to cos x, and T is equals to tan x. So now I can replace everything with this S, C, and T. Now look, it's much more concise, easier to write, easier to understand as well. Sometimes your equation would become so big, so complicated, especially in A2, that things would become very jumbled up and you may make silly mistakes in multiplication, simplification. So in this way, you can improve your work. So now I told you that you can start off with this thing as well. You can start off with simplifying this thing as well. So it's up to you. Now, what am I thinking right now is, what can I do? I can change my tan on the right side into sine over cos. So if I write this thing, sine over cos minus 1 upon sine over cos plus 1. I'm trying to change the right side into the left side. Okay, I cannot move things around. I can just simplify the thing on the right side completely or simplify the things on the left side completely. Now what can I do? If I take LCM on the numerator, in the numerator completely, and in the denominator as well. So I will get sine minus cos upon sine plus cos upon cos. Because you can see there is nothing in the denominator 1. So you multiply this thing with cos, multiply this thing with cos. Over here as well, multiply this thing with cos, multiply this thing with cos. So you are getting this thing which I've written now. Then what do I have? Look, sine minus cos upon cos. This was the numerator. Divided by sine plus cos upon cos. Now if I do the reciprocal, so cos comes up, sine plus cos. So now the cos and cos cancel out. You have the thing which they had asked you to show. This is exactly the left side. So you can see now this thing and this thing same, exactly same. So this is my work complete. In the final part, you can replace the sine with sine, S with sine, P with cos, and if there's any T with tan. So look, I did it quickly, neatly, more efficient. So this is one of the things that you can do if you want to. I have done this in my exam, and this helped me out a lot. So that's why I'm telling you people as well, if you want to try this quickly as well. Okay, so again in this one, I would do the same thing. Okay, sine upon 1 plus sine, 1 plus cos, 1 plus cos upon sine, 2 upon sine. What I can do is I can take the LCM. If I take the LCM, I will have sine 1 plus cos. And over here, I will multiply this thing by sine, this thing by sine, this thing by 1 plus cos, 1 plus cos. So sine square plus 1 plus cos whole square. Then sine square would remain sine square. 1 plus cos whole square. You will use identity. Your a plus b whole square. So 1 plus 2 cos plus cos square upon sine 1 plus cos. And identity, recall the identities that you have. You have sine square plus cos square is equals to 1, and you have tan is equals to sine over cos. So you can see sine square plus cos square. This would be equal to 1. And 1 plus 1 will become 2. So 2 plus 2 cos upon sine 1 plus cos. Then if you take 2 common, you will get 1 plus cos upon sine 1 plus cos. 1 plus cos, 1 plus cos cancel out. So you are left off with 2 upon sine x, which is the same as the one which they had asked you to show. Any questions? Anything? Sanchi, Munib, Rayan.
कुछ समझ आ रहा है?
No, sir.
Okay, I'll do another one. I have done these a million times, so definitely I know all the tips and tricks and everything. I can do it in my mind as well, everything over here that you can see, all of them. But definitely when you will do these, you may take some time, you will mess it up 5 times or 6 times as well. But eventually you will get it. You will learn the new techniques. It's just algebra, simplification. So if you do things logically, so you will get the right answer. Why not? Now in this one, I know what is to be done. Okay, and you always start off with the more complicated part. I think the left side is the more complicated one. Anyone, any ideas? The two identities that we have. No ideas.
Sir, cos square x square sin square x.
Cos square x, you can write it.
1 minus sin square x.
Okay, so cos 4 minus sine 4 upon 1 minus sine square. What next? What can you do more? You cannot cancel out this sine square with sine 4, okay? So you cannot cancel out things in between. You have to take them common out and then see. Whenever you try something, you have to analyze if it is getting you closer to the answer that you want or if it is getting you, it's getting you further away. This is a very logical solution. This is something that you have done very correct. But in my opinion, how would this bring you closer to the solution? The main problem is you have to somehow get rid of these power 4s. So for that thing, my mind would say that I can use the third identity, algebraic identity, a square minus b square. So if I write the cos square power square minus sine square power square upon cos square. Now you can see it is a square minus b square. Now you can write it down as a plus b, a minus b. So cos square plus sine square and cos square minus sine square. And we know that cos square plus sine square it is equals to 1, the identity. So you are left off with cos square minus sine square upon cos square. Now if I separate the fraction, look, the thing, always keep in mind what you want to change it into. If I separate the fraction, so cos square upon cos square minus sine square upon sine cos square. So cos square becomes 1 and sine square upon cos square becomes 1 minus tan square. समझ आया? So using the third identity, algebraic identity, that is one of the things that you can try. Any questions? Anyone? Now I had to figure all of these things on my own. And if I would open up my register from my A level or AS, you would see 5-6 pages all crossed out, everything, so that I can get to know what is the thing that is to be done. However, you will do everything logical, but you won't get to near the answer. So that will all be in vain. So you will try something else, then you will try something else, then you will try something else. Eventually, you'll get to the answer. So if you go through the complete thing, this process of making the mistakes and learning through your mistakes, then you would master this very easily. Otherwise, if you just wait for miracles, this is not a chapter for miracles. It just needs a lot of practice, a lot of mistakes, and eventually you will learn. So you can try all of these. Some of them may take even days for you to solve, but eventually you will get the answer. You will learn new techniques. I gave you the technique over here. Look, taking the LCM inside the diffraction further over here. In this one, what did we do? We took the LCM of the two brackets and then simplified. In this one, we used the third identity. So all of these are the basic algebra that you have learned in your O level and IGCSE. You're just trying out different things and eventually you'll reach the answer. Okay, so you can try more of these. You can take this as a homework, take a screenshot. Balki, I will share you this worksheet. Remind me on the group. You can try these all. Start with the simpler ones. Okay, start with the simpler ones and then slowly, gradually increase the difficulty. And group, people can share your solutions, share your problems. I'll give you some hints if you are stuck somewhere. And always think of the next step. If you are trying to do something in your mind, you should think for 2-3 steps ahead. For example, if I do something, then what would be the next step? What will I get, and how will that help me, or will that just complicate things for me? Think 2-3 steps ahead. Okay. Think of the consequences of your one step that you're doing in the starting. And this needs practice. This needs practice, definitely. Analytical skills, your observation. Okay. Now we move on to the next part. Now on the solution part, solving part of this trigonometry. We learned in trigonometry right now previously that we have the quadrants, the cast system, CAST. Now there are two variables that I will introduce you. First variable is theta or x. That is the variable that you're trying to find. Your actual variable for which you are trying to find a solution. You will find solutions for your x or your theta. For example, the question is sine theta is equals to 0.5 something. So theta is the actual variable. You're trying to find the theta. And this theta, it can be positive, it can be negative, it can be acute or obtuse or reflex or more than 360 as well. Can be any angle. Then this theta will always be made from the positive x-axis, which is this one. This is your positive x-axis. So your theta will always start from the positive x-axis. And if you go from this positive x-axis in the anti-clockwise direction, so you will have positive theta values, positive x values. Or if you move in the anti-clockwise direction, you will have negative theta values. So if you're moving like this, you will have positive theta. If you're moving like this, you will get negative angle. For example, negative 30 will be like this, negative 30. Positive 30 would be this positive 30. So if you're moving positive 150, so positive 150 will be in this direction. If it is negative 100, so negative 100 will be like this. Okay, give me a second. Copy this down. Okay, so now if I ask you to plot some of these angles theta on your grid, on this, not your grid, what do we call this? Simple, this cast thingy. Okay, so let's suppose your question is, they're asking you to plot your theta is 40 something, 40 degrees. Now this is positive 40. So this means it will be anti-clockwise and 40, like this. If your theta is 210, positive, again positive. So 210 will be in the third quadrant because it is more than 180. So this much is 180, right? This is 180 and then something more. So 180, so total would become 210. And you have moved in the clockwise direction. Oh, sorry, anti-clockwise direction. If your theta is minus 75, so look, this is a negative theta. So this means now you would move in the anti-clockwise direction. If your theta is 310 positive, so 310 will be in the fourth quadrant because it is positive. You are moving anti-clockwise. If your theta is minus 200 degrees, so it will be in the second quadrant because it is more than negative 180. If your theta is, let's suppose, 500 degrees, so this one is more interesting. This would become positive. This is positive 500. So one cycle, this becomes 360. 360, and then how much more do you need? 140. So 140 more would be over here in this quadrant. So this is your 500 degrees. Further, 360 and then plus 140 more, so that your total angle becomes 500. Do you get it? If you have, let's suppose, your theta is minus 400. So 360, complete 360 negative, and then 40 more. This would be your total minus 400. And it is clockwise. Any problem? Following the definition of theta or the variable x that I am giving you, you can see all of them are from the positive x-axis. And the theta can be negative or positive. It can be acute. You can see 40. It can be obtuse. You can see where is obtuse. I've given you, so this one 501. You can see it's sort of a, no, not, there is no obtuse example I've given you. It can be in the second quadrant. It can be reflex look more than 180. It can be even more than 360. I'll give you the example. And it will always be starting from the positive x-axis. And if you move anti-clockwise, it is, you get a positive theta. And if you move clockwise, you get negative theta. So this is your theta x And now you have another variable. I call it alpha. There's another name for this as well. I think it is critical angle, or I forgot the actual or the mathematical terminology for this thing. But I call this alpha. What is this alpha? This alpha is always positive. It is always with the x-axis. With positive or negative x-axis both. I can draw this alpha with both of these, the x-axis or the left side or the right side. But with the x-axis. This will always be acute. Acute means less than 90. And is there anything else? No, I don't think. Okay, so using this definition, I can place, there is no direction for this alpha, okay? Over here for theta, we had the direction. If you move anti-clockwise or clockwise, then we get positive, negative values. Over here, direction is not important. So if you have this these definitions for alpha, following this definition, I can place now alpha in the coordinates like this. So here alpha can be this, alpha can be this, alpha can be this, alpha can be this. So I can see all of these angles, alpha that I have placed over here, are with the x-axis, positive or the negative. And all of them are acute. Look, you can see all of them are less than 90. And all of them are positive. So what do? They ask you to find the alpha for each of these thetas that we have made. Now that this becomes more interesting. Copy. Paste. Now the question is, where should I write the question? Find the alpha for each of these theta. So for the first one, you can see that you have this theta and your alpha is also the same thing. It's with the x-axis and it is positive. So in this case, your alpha, it is equals to theta. Because you can see both of them are acute, both of them follow the same criteria, right? And the theta is also following the criteria of alpha. So it is acute, it is positive, and it is with the x-axis. So this is your alpha. Over here, we know that alpha would be this thing. And you can see how will you find alpha? This would be 180, 210 minus 180, which will be 30 degrees. So in this case, your alpha is 30 degrees. Because with your theta as 210, the angle this 210 is making with the x-axis, the positive angle, it is 30 degrees. For this one, this would be your alpha. And it is again same as theta, but it is positive. I told you there is no direction for alpha. Over here, this is your alpha. So alpha will be 360 minus 310, 50 degrees. Over here, this is your alpha. Acute with the x-axis. This would be 200 minus 180. So 20. This would be your alpha. which will be 140 minus, this would be 40. I think yes, 40. Total is 360 plus 180. 360 plus 180 is 540. And 540 minus 500 is 40. For this one, this is your alpha. And alpha is 40. Do you people get it or not? Any questions? So now with this knowledge completely, we can make a general diagram to find theta using alpha or to find alpha using theta, which is something like this. So in the first quadrant, we know your theta is the same as your alpha. In the second quadrant, you can see your theta will be 180 minus alpha. In your third quadrant, it will be 180 plus alpha. And in your fourth quadrant, it will be 360 minus alpha. Getting it? If this is your theta, you have the same alpha. This is your alpha and this is your theta. So 180 is the total. I'm subtracting this alpha. I will get the theta. I have this total. This is theta. 180 plus this alpha will give you the theta. Similarly, this angle. Total we know it is 360. 360 minus this part. I will get theta. Okay. These are for positive angles. For negative angle, what will happen? If your theta you want it, you have it in negative angle. Your theta is negative. So this would be your theta log. So your in the fourth quadrant, your theta will be negative alpha. You're just moving in the clockwise direction. Over here, your theta will be minus 180 plus alpha. This will be your in the third quadrant. In the second quadrant, it will be minus 180 and minus alpha. And in the fourth quadrant will be minus 360 plus alpha. This is your total 360 negative. And then you are subtracting this alpha. You don't need this alpha. So plus alpha. Getting it? Any questions? Anyone? Any questions? Anything? Otherwise, copy this down. This is the essence of the complete topic. Being able to understand how to find theta using alpha or alpha using theta. Basic angle. The alpha is known as the basic angle. Okay. You people can try these. Find the alpha for each of them. Try all of these and then randomly ask. Any of you do? Give any of the answer? Tell me the answer for this one. For the part B.
40 degree.
How much? How much?
40.
Ah, 40. Nice. Munib, what is the answer to this part C? What is your alpha? Munib, बेटा नहीं बेटा?
Yes, sir.
हाँ क्या है?
60.
नहीं. This is your alpha. How much will this be? हाँ बताओ.
सर 20 डिग्री होगा ना?
Yes, 20. Because this is 180 total on a straight line, 180, and 200 minus 180 is alpha. Or you can use the formula as well. These formulas that we learned over here for positive angle, for negative angle. Again, you could have used these as well. Otherwise, simple basic angles you can use. We know in the third quadrant for positive angles, theta is equals to 180 plus alpha. So alpha will be theta minus 180. Ryan, what is the answer for this one? Part D.
40 degrees.
40 degrees. Yes, 40 degrees. Good. Who's left? Mohit. How much is this? Part A. Mohit है नहीं है? Mohit gone. Abhiyan.
70 degrees, sir.
Yes, good. Nice. They won't ask you questions like these, but this is the basics. Okay, you have to understand these things. You would have something else, you would have questions like these. Like these. Sketching, or we learn how do we sketch it, but more like these types of question. They will ask you to find the values of theta. So everything over here, the last few steps will be the same as the things that you are doing over here. Finding alpha using theta or theta using alpha. So, but all of this is very, very important. And what do? We still have time, or we don't have time? There's another class. Okay, so this is enough. I think more than enough for a single class. We have done a lot of things. Go through these things again. And in the next class, we will connect everything over here that we have done everything together. And you will see how we do a question of trigonometry, a past paper like question. So next class is a very important one. Everyone should join. Don't miss out anyone. And practice, revise this, probably make notes, and I think that is it for today's class. Okay.